why we need this particular course and why it is important. In addition, we introduced the fundamental notations of how complexity analysis is done, right? So you have the big O, you have theta, you have omega, right? And then you have the corresponding small letters too, right? And then we concluded saying that most of the time when we talk about complexity analysis, we talk about big O. Okay? It's kind of hard to get the exact notation. So as long as we get a big O, we are generally good enough to compare algorithms. We don't compare algorithms at the theta level and omega level and things like that usually. Okay? Can be done, but it's tough. Okay? Now we get into different types of techniques, if you will, to come up with good algorithms to solve problems. Okay. Now we are still in the realm of techniques as opposed to what I would call it as business problems, right? If you ultimately, what do we solve as computer scientists? We solve business problems in the industry, right? But once you understand the business requirements, then you come up with a design and the solution and all that, it's time to implement the solution. That's where you get into different types of, I'm getting crosstalk, guys, please mute yourself. Everybody, Chakravarti, I made you the host. Can you mute all of them except me, please? Okay. So ultimately, I think Chakravarti. What happens is the business problems, by the time you come to realizing the solution, you have to implement it, right? So when you're implementing these things, you get into the searches, sorting, building tree structures, right? So what is divide and conquer? Go to the next slide, Andy. This is a nice slide. Huh? When you want to succeed as much as you want to breathe, that's when you will be successful. Great quote. I just picked it up. Go to the next slide. So in this particular case, sorry, one slide back. So three particular things that we'll talk about in divide and conquer are, of course, the binary search, right? That kind of lays the foundation. Then I'll talk about merge sort first. Then we'll get into quick sort. Those are all divide and conquer techniques. There are a lot of other divide and conquer techniques too, like matrix multiplication, for example. Okay. If time permits, I'll give you some examples of matrix multiplication. Got it? Okay, let's go to the next slide. Students, you may want to copy this link, bigocheatsheet.com. Nice link. Okay, so it lists all the algorithms that are there and what is the time complexity and so on. Very useful link. Teachers, it's useful for you too. We are clicking on that link, go ahead. No problem. I think it's bigocheatsheet.com. See that? Know the complexities. It's a wonderful site. Gives you a good overview of all the various logarithmic scales and the graphs and all that. So you can see for array, stack, single linked list, doubly linked list. We'll get into all of those things as we go along. Okay? I mean, the idea is not to memorize it, but just to generally get an idea of what kind of time complexities we are talking about. Okay? Great. Thanks, Andy. Go back to the slide deck. Okay. So just as an introduction, so these are the looking ahead into the roadmap, right? So we'll be doing the divide and conquer. After this, we'll get into, I think, greedy, and then after that, dynamic programming. right? So what is the divide and conquer methodology? The idea is to divide a problem into two subproblems, okay? And solve each of those subproblems independently. Okay. Third is combine the solution to the subproblems to form solution to the original problem. We use that everywhere, right? In all walks of life. Particularly Indians, we are very good at knowing what divide and conquer is, thanks to the British Raj, right? That's how British conquered India, right? They divided the kingdom, the entire India, into different types of kings and all that, right? And then they conquered each one of them, and then they formed a big solution called the British India. Turns out that divide and conquer works in computer science too, okay? So that's what we'll focus on. Greedy is very interesting too. When we get to that, I will give you an example of solving 8 queens problem. A lot of you might be playing chess in India, right? Now everybody plays chess in India almost. So how do you place 8 queens on a chessboard? Classic example where we use the greedy approach. Traveling salesman problem too. We use the greedy approach. And then there are some pitfalls for that. So we'll understand those things. Then we get into this technique called dynamic programming. There's nothing dynamic about it. It kind of looks like almost combination of, I would say it's a divide and conquer, like where we break the problem into 2 subproblems. But whereas here, when you break them into subproblems, there's an overlapping subproblems. Okay? Then slowly we start merging the subproblems together for larger and larger till we solve the full problem. We'll get into examples like knapsack. So we'll study knapsack problem, how to fill up a knapsack and things like that where we use dynamic programming. Next slide. Okay, so here is the outline for divide and conquer strategy. Okay, so in your exam, I know that they ask, okay, tell me how you solve divide and conquer problems. So these are the 3 steps. If you list, you will get, if it's a 10-point question, you get 10 out of 10. Break it into 2 subproblems that are themselves smaller instances of the same type of problem. Okay, so it's the same problem, but except you broke it into half. And you do that recursively, meaning again you break the subproblem recursively into 2 more subproblems. Okay, at some point you are left with the lowest unit of subproblem as far as your problem space is concerned. You get the answers, and then you go up, bottoms up, to combine the answers. Okay, that is the theory. So I'm going to show you a nice animated example for you to understand the theory in this chapter. Next slide. So here is an example, right? So I listed one example. Where do we use it in real life, right? Phone book search. Because these days nobody really has a phone book, right? You just go to Google or Google search or do something like that. But imagine the telephone book. I don't know if the Indian telephone and telegraph people give that big directory, yellow pages directory. If you want to search for a name, what do you typically do in a phone book? You go to approximately middle of the book, right? Let's say you're looking for something like Lavanya. I don't know why I picked Lavanya. I don't know any girl by the name Lavanya in my life. It just came to my mind. Okay. Oh, there is a movie actress, right? Lavanya Tripathi. There is it. Subconsciously, I think I remember her. So I just go to the center of the book. Let's say, okay, L. Whatever page I picked, is that greater than the letter in the page, whichever page I picked. Let's say in the middle of the book is M. So L is less than M. So I take the first half of the book. Anything beyond that, I eliminate, right? Then I do again maybe another half and things like that. So you're basically dividing the problem space into smaller and smaller spaces to solve your problem. There are lots of other examples where you use divide and conquer, right? Can anyone name at least one more example of divide and conquer in real life? Faculty members are welcome to put it too. Okay, so binary search algorithm, right? Did I ask you to write some kind of a program or something last class for binary search? I did something to that effect, if I'm not mistaken, right? I didn't get a chance to see the community if anyone has posted, but I think I gave you this assignment. Okay. So what are we doing in binary search? We also did some examples in the class too, right? So we are repeatedly halving, right? If I can use the word halving word, is the main idea behind this method, right? The advantage we found out was, especially when it's a sorted array, right? If it's unsorted, binary search doesn't help. It will be just as bad as the regular search. So if it is a sorted array and you're doing binary search, you are able to do it in log n comparisons, okay? If you do a linear search, we said it's going to be big of n, right? You remember that? If I have A1 to n and sequentially I search from first element to last element, potentially you could take n iterations to get the element. Whether it's a sorted array and you do a binary search, then you can do it in log n. Log n is a much better algorithm than a order of n algorithm. Next slide. Okay. Now you can see how much saving, oh, sorry. Okay. Now you can see how much saving you can get in terms of time, right? So if n equal to 100, log 2n is 7, n equal to 1000, log 2n is 10. See, as your input size grows, you can see instead of searching 1000 times, you can do it in 10 steps in log 2n here. Same thing with 10,000, you're able to do it in 13 steps. See the power of it, right? So the trick then to come up with an algorithm, okay, let me put something in the chat for Vitam. Put this for, I'll say, somebody is unable to hear. JNTUV and Vitam. Okay. Vitam and JN. Algorithm that I asked you to review and do some programming is what you take the midpoint. Okay. So left is 1, right is 12, midpoint is 6. Okay. Go to the 6th midpoint. Okay. Go to the next slide. So if V of mid is less than or equal to X, because X is what we are looking for. If V of mid is less than or equal to X, that means you're not going to find anything left of that, right? Because X is larger than V of mid. So you throw away the left half. Okay, next. So once you throw away the left half, then what do you do? Visually, you know that. Now you are going to again do the midpoint, right? So from 45 to 86, you will select the midpoint. Midpoint is 70. So midpoint is 70, right? It has to be less than 73. That means you eliminate the right half 73. Now focus on left of 73, right? So that is how the algorithm works. Now, once you reach the one element and you still can't find the value, that means that value does not exist in the array. Okay. Based on this simple explanation, you should be able to write a C program, right, for that? You need some kind of variables to keep track of left, middle, and right. You need a loop because it's a for loop, right? So, and of course, you know the array size. In C programming, array size has to be declared. So you should be able to easily write that algorithm, or rather implement that as a code either C or C++. Next slide. Yep. That's what we said. Throw away the right half and then continue. So you can see how now we get the idea, right? So now again you have the midpoint V of mid is less than or equal to X. Okay, then now you throw away the left half. So left, right, left, okay? And next, so now you're left with those three elements. V mid is less than or equal to X. You can see the animation is given in the slide, right? So that way when you review the slide, you would know how the algorithm is working. Continually hit return. Now you're throwing away the left half. Done because right minus left equal to 1. There is no half there, right? There are only two elements. Okay? That means you did not find the element. Okay? So how many times you have done really? You went right, left, right, left. In the simple case of 12, I think about 4 times. 3 times, I think. 3 or 4 times you did. I think 4 times. As opposed to doing it 12 times, right? If you do linearly, you go from first element 12 all the way to 86. So you cut it down by what? 1/3. 1/3, no, you cut it down by 75%. Okay, next slide. So here is that full function for binary search. Okay. So you can see that you have the left index and the right index. Right is nothing but length of X. Okay. Typically length of X is given in C programs. Whenever you pass your array to a function, you specify the size of the array in C programming. Okay. Great. Then what are we doing here? The same thing. While R minus L greater than 1, how do you come up with the midpoint? You use the floor function. Floor left plus right divide by 2. Why do you use the floor function? That takes care of the odd number of locations, right? Because you can't, sometimes if you have odd, where do you take it? Do you take the lower unit or the higher unit, right? That's why you use the floor there. Okay. And then you have A less than or equal to X of mid. If so, then you go to the right. If it's the other way around, then you go to the left. That's what it says. Pretty simple algorithm. Huh? Next slide. Now, that is fantastic, right? But then how do we get the array in the sorted way? If I give you an unsorted array, and then I say you need to apply binary search algorithm to find an element, first you need to figure out how to sort the array, right? You could use bubble sort. You could use selection sort. There's something called radix sort also. I somehow vaguely remember that. Okay, there are all kinds of sort techniques, right? Turns out, as some of your classmates have put in the community in the beginning, bubble sort is an order of n squared. So is selection sort. Okay? It takes an order of n squared time. If there are 10 elements, it takes 100 iterations to do that. Okay? So there is a fantastic technique called merge sort. Given an unordered array, how do you sort it in a better time than order of n squared? So we get into this beautiful program called merge sort, where it turns out the order of the algorithm, the big O is n log n. So remember, n squared is worse than n log n, right? So n squared 100 times 100 is 10,000. Correct? Yeah, 100 times 100, 10,000, order of n squared, 100 element array. By doing merge sort, now you're getting it to n log n. N is 100. Log of 100 base 2 is how much, Andy? 6. I mean, technically 7. Okay, let's say 7. 2 raised to 7 is 128, right? 2 raised to 6 is 64. So 100 times 7 is 700, as opposed to 10,000 steps. right? I'm using steps as in a loose way, okay? So that is the advantage of merge sort. Now imagine for 100 element array, it is like that. When you have a 1000 element array, the time adds up, okay? Okay, so now the next focus would be to understand merge sort. So let me pause here. Are there any questions related to binary search? Anyone, feel free to ask questions. No questions? Okay, that's excellent. Either you're all sleeping or you really understand it. Okay, let's go to the next slide, Andy. I'm turning on my video. Hopefully I won't crash. Thank you, Sri Prakash. No doubts. Okay, great. So what is the motivation? Merge sort is nothing but, as it says here, if I have two helpers, I would give each helper half the array to sort. Then I get back the sorted subarrays and merge them. It's the same thing, right? If you really look at it, that's what we do even in real life. If you look at JNTU, right? Let's say VC Garu needs to give a presentation to Chandrababu Naidu, okay? On different aspects, the technical aspects, the finance aspects, the administration aspects like number of students, teachers, and things like that. And he needs to put together a PowerPoint presentation. Okay, what does he do? He will call Chakravarti Garu and says, hey, give me some PowerPoints related to Moocs. How are we doing on Moocs? He'll call up the registrar to say, hey, give me some slides related to the students and faculty and all that. Okay, he'll call the finance department guy and say, hey, give me the budget analysis, how much we are making, how much we are spending, how much money we need, and things like that. So each of them would be, they are all their helpers, right? They're going to sort all the mess out, put the numbers in the right way. Then VC staff or VC himself will put those slides back together in a nice, in a very sorted, organized manner. Okay. Another name for sort is really organized, right? Okay. Next slide. Now that is what happens in India and British Raj, right? A helper is a helper, a helper is a helper, and so on. Okay, and that's a different story altogether. Next slide. Okay, so now Chakravarti will run this slide deck, and if you want, please feel free to explain, or anyone can explain. It's a nice animation. You can watch it as a silent movie. Okay. Continue. So what did we do? First step. Okay, go back one slide. Go back. So divide the problem into two sub-problems, okay? PVP Siddhartha, you have been very active. Is your audio working, Andy? If any one of the faculty members, as they go through the slide, want to explain, please say so, raise their hand, or say you want to explain. Then we can unmute your audio, and then you can speak. Who wants to take up the challenge, please? Remember, the helper gets other helpers. That means you're dividing again. So the 8 HEMGBKAQ got divided into 2. Right side got divided into 2. Okay. Now again, can you divide 4? You bet, you can divide. See that? HEMGBKAQ. That's what merge sort does. First it divides. Okay. Before you put the next slide, What do you think would be the next line? Can anyone guess what the next line would be once Chakravarti garu hits return there? You can put your guess in the chat. Would you further divide 2 into 1 each? Okay, that's the question. Would you divide those two, HE into H as one block and E as one block? I simplified the question. Same thing, would you divide MG into M as one block and G as one block and so on? Yes or no? You have 50% chance of getting it right because it's only yes or no. Okay. SVCW said yes. Let's see other colleges. What do they say? Couple of more answers. I need a few more answers. It's fun, huh? Believe me, algorithms is the most fun class that you will ever have in computer science curriculum. I only got one answer. Okay. Kite says yes. Okay. Anybody who will say no? Okay. Sri Prakash's division will be continued until array size becomes 1. Is that so? Anyone? That means everyone is saying yes, or is there anyone who will say no? Any faculty member wants to answer that? That's good. A lot of people are, I got 3-4 answers. One more. I thought I'm waiting for somebody to say no, right? Okay, Chakravarti, time to go to the next slide. We'll see if that is true or not. Did it change it? Do you see that? You are absolutely right. Each of them became, division will be continued until array size becomes 1. Isn't that what happened there? You got it. Okay, next. Now no more division. Now what do? Now we start merging. And when we merge, see what happens now. Go to the next slide. So what just happened? What is the difference between the bottom row and the one that is highlighted? Who can explain that? Please feel free to explain what just happened. That's only part of the answer. Can you expand your answer? Compare and sort. Okay. Can you expand that answer further? Compare what? You got it. Pairwise. Okay. The pair that got subdivided, you're comparing that pairwise. That is what happened. So when H and D got broken, they were part of it. You compare and you sort them. First element and second element. You got it. Perfect. You are on a roll here. I'm super excited. A lot of answers today. Great. Go to the next slide. Okay. So now you compare EH, G, and M. Okay. Somehow you have to compare EH block and GM block and sort them. That is why if you see what Sri Prakash College they have put there, in essence that's what they're saying. You're comparing the first element of the first array with the elements of the second array. Not necessarily second element, but you will see once you put the logic up there. But that's what you're doing. You're comparing those two arrays. You're trying to sort them out. Okay. Now, if you look at the highlighted rows there, the alphabets within those arrays are sorted. Now, before you hit the second button, okay, before you hit the second button, just for the fun of it, if somebody wants to write the algorithm, let's take just the two left blocks, E, G, H, M, A, B, K, Q. So how do you compare those two arrays? Let me ask the students, okay? Do you know how to compare those? Okay, 1 second, hold on, Sri Prakash. Don't put anything yet. Okay, I'm seeing PVP Siddhartha picture here. Students, raise your hand if you know how to compare those two arrays and create a sorted array. Doesn't matter which algorithm. Do you have confidence in your C programming skills to write a program where I give you those two arrays, E, G, H, M, A, B, K, Q, and you can create a sorted array for me? I'm seeing the picture of Siddhartha. Okay, students, raise your hand if you think you can do it. Okay, I see half of the class, mostly boys. I see a few girls. If I see the full video, maybe they can. Okay, one girl raised the hand. You raise it high. 2 girls, 3 girls. Wow, girls are beating the boys, or are the boys behind the girls there? That's good. You can write it, right? That's all it is. So there is nothing great about merge sort. If you know how to write sort algorithm between two arrays, you should be able to write merge sort also easily. Okay, go to the next slide. See that? Now that gets sorted. Next slide. All sorted. Amazing, huh? How merge sort works. I mean, these are the kind of algorithms which, once you solve it, you get very excited. Okay, next slide. I think I gave the algorithm code also, I think, close to the algorithm. Hey, okay, let's take a break here. I need my break. Or we'll finish this and we'll take a break. How about that? Okay. I'm just thinking, should I take a break now or should I leave the slide there? How about I give a 3-minute break? Okay. Thank you, sir. Thank you. Because Chakravarti knows I need my tea. 3-minute break, but leave the slide deck there open. See what that slide is doing in the meantime, okay? However, if you see that one, remember it's a log, and since I know it's a log and algorithm, 16 is what to the base 2 raised to 4, right? I could have instantaneously answered it's 4 times it's going to be called. Okay. So once you come to the lowest element, then you start merging them, y left and y right. Now this is another beauty of recursive algorithms, right? The algorithm is so easy to understand. Okay, keep that in mind. Go to the next slide. Opening my windows here. So, here, main thing is to see how to merge 2 sorted arrays into 1 single sorted array. We have already seen some young ladies raising their hand that they know how to do that, right? So we will probably make them explain. Go to the next slide, please. So you will see a beautiful animation here as to what is happening. Okay, I will talk less and then let the slide speak for itself. So you are comparing 12 with 15, 2 sorted arrays X and Y, and you want to put them in Z in a sorted manner. You compare 12 and 15 first, okay? Now, which of those two elements would go to Z? It goes, go ahead, put it in the chat, 12, right? Remember, it has to be sorted. So 12 goes there. Once 12 goes there, what happens to the pointer pointing to 12? Pointer should move to next element in X, right? Not in Z, but in X. Because the element X, 12 has moved. Now we have to go to 33. That red arrow should go to 33. Once it goes to 33, then you compare that red arrow of X to the red arrow of Y. Right? You see how the arrows are moving? So 33 and 15 are compared. So now 15 goes to Z. Go ahead, hit the slide. Hit, okay. One more hit, then the arrow moves. See that? See how the arrow, now 33 and 42 are compared. This is what one of the colleges was saying, right? Sri Prakash. You compare the first element to second element. I mean, not really. Because to begin with, you compare both the first elements. Then obviously there's a difference of 1 until a situation happens where you're comparing same indexes, right? Like in the case of 33 and 42. So continue like that, Andy. Hit a couple of slides like that. I'll be quiet. So X low manam we reach the end. So then only elements remaining are Y elements. So if we continue, then 65 and 75 would come there. Okay. So that is the comparison operator. After we compare, then what do? We have to merge, right? Okay. So here is a function for merging X and Y. Okay, you get the length of X and length of Y. And then you are creating some zeros out. I do not know why it is being done, but let's see why it is done. Continue. You're basically initializing the array to zeros to begin with. Code, then we can analyze the code. Yep, keep that. There you go. So while IX, what is IX here? IX is 1, IY is 1. Remember we have X, Y, and Z, right? 2, Y of IY. That animation code is what we are writing here. Okay. And then depending on which of the indexes are moving, you keep track of that. Okay. So this piece of code is what gets you that merged array. Okay. Can somebody tell me what the second statement is doing? Z equal to zeros, 1, comma, nx plus ny. Is it basically initializing that array to all zeros? Nx plus ny gives you the total length of the array, right? Total length of the array of Z should be length of nx plus length of ny. We know that. Correct. So starting from index 1, I mean, technically it should be starting from index 0, right? So you're basically initializing the elements of the array. Because in C, if you do not initialize the elements of the array, you'll get garbage. You probably would have learned that in C programming language. You have to initialize your arrays. To zero out the values to begin with. Then you do that loop. Okay, good. Nice code. Huh? I want you to trace that, okay? Later you'll be tracing that code too in the class. Next slide. So you merged. Then what happens next? Okay. Then after you merge, once one array is over, then you just have to copy paste the rest of the array elements, right? So in our case, y had some additional elements. So the second while loop and the third while loop takes care of the case where one of the other arrays is done. So you just have to copy the values. So in the case of copying x values, you have one while loop, and in the case of copying y values, you have another while loop. Okay, continue. Okay, so here is a merge sort, which we kind of saw earlier too, right? So base case, merge sort left, merge sort right. We already covered that in the beginning. Continue. So you have the same thing for merge sort left, how you do that, and for merge sort right, how you do that, right? In every merge sort left as well as merge sort right, again the left one would have left and right. Remember that, right? It's a recursive call, right? You're dividing into two. When you divide into two, one is called left, one is called right. So it's the same piece of code that gets repeated in both merge sort left and merge sort right. Okay. So that is what that code is, merge sort left and merge sort right. The one at the beginning that we have seen. It takes a little bit of practice to get it right, okay? The concept is explained, but once you write it, then you will be appreciating the code more. Write it on a piece of paper with test values to appreciate this, okay? So you can actually divide, how are you dividing? Give me a second. I have to go back to, okay, now I can. There's a way of doing divide and conquer where you can actually take 2 by 2 block matrices with only 7 multiplications. Okay, so you can see you did some theory there where you do 7 multiplications and 18 additions. Okay, I'm not showing the algorithm yet. Okay, now there's this guy called Strayson in 1969 showed a mathematical study where you can partition A and B matrix into half n by half n blocks. Okay, then he computes the matrices, whatever he comes up with the matrices. Okay, then you're conquering, meaning you're doing the actual multiplication, and then the merging, that is combining. Okay, what he has shown in the process of doing that, instead of getting order of n cube, he got it to order of n raised to 2.81. Not 3 totally, 2.81. Okay, you might say, hey, what is the big deal between order of n cube versus order of n 2.81? Big difference. Huge difference as the matrix sizes grow. Imagine multiplying it 1000 by 1000 by 1000. Matrices, 1000 by 1000, 1000 by 1000, 1000 by 1000. Okay, then that minute difference of 0.19 that he achieved, n over, right, makes a humongous difference. Okay, again, fantastic case of divide and conquer. Unless I'm a mathematician, I would probably not even understand Strassner's paper. Or maybe I can understand if I spend a day. I don't know. Okay, but here is another great example of where divide and conquer is used. Okay. Now, when it comes to matrices, right, there are a lot of other issues, right? If you take a class on numerical methods, I don't know if it is taught in undergrad curriculum or not. I took that course when I was doing my MTech in computer science, where we learn about sparse matrices, right? Dimensionality of matrix. There are a lot of properties related to matrices which come into play in coming with the right algorithm. Okay. You can see here some studies show that what kind of speeds he has achieved on higher computing machines. Okay. So for those of you who are more mathematically inclined, I would ask you to do some research on this particular one. Very interesting case studies on that. Okay. Remember I mentioned something called Master's Theorem. I just put some slides here. The intention was those are more my working slides at this point. They are not really formulated as a formal lecture yet. This is my cheat sheet. Remember I said my slides are always working slides. There are some things there. Please feel free to read them, understand them. I'm not really teaching Master's Theorem here. I just put some slides and then figure out same thing. You will see what that Master's Theorem is. So whenever we have to come up with these n log and stuff and all that, we are relying on Master's Theorem to do that most of the time. There are some cases where Master's Theorem does not apply. Okay, then you have no choice but to use your skills in big O analysis to come up with the whether it's a log n or n log n, n cube, whatever the case may be. Most of the divide and conquer algorithms, what the authors do is they try to apply this Master's Theorem and tell them what the order is for them. Okay, most of them, but it's not applicable for all of them. You can see here where it is not applicable, right? If Tn is not monotone, that series is not monotone, like sine, sinusoidal waves, that's not monotone, right? And then Fn has to be polynomial. So if it's not polynomial, you cannot apply. Okay? Cannot apply for Tn equal to T square root n, right? So rule of thumb, most of these things can be applied, but there are cases where it cannot be applied to. Okay? So there's some examples I put there. I'll check with some faculty members. If faculty members say, hey, let's go deep into Master's Theorem, I'll be happy to do that. But I don't think that's part of your syllabus though. Okay? Let me stop there. Questions, comments?